Hi, I'm going to tell you about Wada Farms and their potato box filling machine and the engineering project around it. Wada Farms is a global producer of potatoes, producing millions of pounds per year. At the end of their process, they have a box filling machine that currently experiences many failures. These failures cause them to lose time and money. This is a video of some of the things that we observed. As you can see, a lot of interconnected systems that were very complicated. Right away we noticed that there were some things that looked out of place. Things like potatoes jammed where they shouldn't be, dirty valves, sensors wired up rather than fastened, machinery in disrepair, and machinery that had not been repaired properly. To further understand this, we performed a functional decomposition. This was what we came up with. To identify the root cause of these failures, we performed a root cause analysis. There are many different ways to perform a root cause analysis. Some of the methods that we used were the fishbone chart, a Pareto chart, and a fault tree analysis, shown here. These all pointed strongly toward the braking system. For our concept generation, there were some limitations that we needed to operate under. First, there was already a system in place, there was already much machinery in place, and second, modifications to their PLC would be impossible. Further, for the braking system, the concepts, we focused on the customer needs, focused on giving them more control, reducing maintenance, and being least intrusive to the existing machinery. These were some of the concepts that we generated. For concept selection, we focused on the customer needs, specifically the safety, the alignment, the loading, and reducing the box failure rate. The concept that was selected was the single arm brake pad and guide rail. The previous system operated with a two-stage piston cylinder and spring device. The spring applied constant pressure, controlling the depth that the box would travel into the station, while the cylinder would apply pressure once the box was in place to hold it while filling. The first prototype was brought to install, but was rejected upon discovering the two-stage system. Prototype 2 was developed with a two-stage, two-piston device that used a regulator to control the constant pressure. Prototype 3 was installed and operated. For our final build, design was simplified further for manufacturing and was installed. Here is a video showing its operation. To measure the success of our project, we collected data before and after our installation. These are the results. As is evident, we greatly reduced their rate of failure and increased their time to failure. Our recommendations to Wada Farms were to apply this solution across all of their stations, to follow the maintenance schedule that we generated. In conclusion, we reduced their failure rate, we reduced their calibration and maintenance time, and we saved them money.